Welcome back. 6.7 Quadratic Inequalities. So basically, at the heart of solving inequalities, it's really important to recognize what the inequality is stating and for what values creates a true statement for that inequality. So now, when we start getting a little further into these quadratics, I want you to think about and be able to visualize what it means for a quadratic to be greater than 0 or to be less than 0. I want you to think about that 0 being the y value. So for what intervals, now we talked about this on one of our last lessons where we talked about what are the intervals where f of x is less than 0. So where y is less than 0. So as we get a little bit into this a little more, maybe I can draw it out for you so you can understand it a little bit better. So the first example, an exercise, says determine if each of the following is a solution to the inequality given. Show your work to justify your responses. So simply in A, B, and C, all we're going to do is we're going to test, whoops, I lost it. We're going to test the value they give us. So I'm going to remind you that when I test like this. So I make sure I do not mess up my signs. So basically what that means is that wherever there's a parenthesis, that's where an X appeared. Now you can put this whole thing into your calculator or you can do it by hand. So this one is 16 minus 12 minus 10, which is the same thing as negative 6. So is negative 6 greater than 0? And the answer, of course, is no. So x equals 4 is not in the solution. So how about for B? Again, we're going to test it. 2x squared plus 13x minus 7. And we're going to test whether or not that is greater than or equal to 0. So we're going to put our 2 in here. And once again, we can put this whole thing into a calculator and come up with 27. Is 27 greater than or equal to 0? And in this case, yes. X equals 2 is a solution to, oh, you don't say 2, well, to this inequality. You don't have to be quite so specific. All right, so let's take a look at C. And this is where it gets a little tricky with that negative 3. So I'm going to remind you, squared minus 12, and we're going to test whether or not it's less than 0. So wherever there's a set of parentheses, we're going to put the negative 3. And my advice is put this exactly the way it looks into your calculator. Because if you don't, and you do negative 3 squared, you're going to come up with a negative 9 instead of a positive 9. Because negative 9 squared, I'm sorry, negative 3 squared is negative 3 times negative 3. So this turns out to be positive 9 plus 3 minus 12. And that turns out to be 0. Is 0 less than 0? And the answer is no. No, x equals negative 3 is not in the solution. Okay? Pause, write down what you need to, and we'll move on. So most of the time, there are an infinite number of solutions to an inequality. The solution set of inequalities like these cannot be written in roster form, where you write out the answers 3, 4, 5. All right, so in exercise 2, we will explore how to determine the solution set by using tables on your calculator. So we don't necessarily have to use the calculator because you don't have it at home, but we can kind of just make do for now. So A says solve the corresponding equation for equal to 0 algebraically for all values of x. So what they want us to do basically here is take our x squared plus 2x minus 3 equal to 0 and factor it, because if we're solving it, that's how we solve a quadratic equation, and we get x minus 3. Oh, no, it has to be x plus 3 and x minus 1, right, in order to get a positive 2. So you have x plus 3 equals 0, minus 3. So we get x is equal to negative 3, or we have x minus 1 is equal to 0. Add 1 to both sides, and x is equal to positive 1. So we know that when x is negative 3, my y is 0. And we know when x is positive 1, my y is 0. All right? Now, using your calculator and the equation, fill in the table below. But if you don't have your calculator, we can just substitute in. But let's not spend time doing that. Let's just take my word for it that these are the numbers that come off your calculator, or once you do your substituting, that's what you come out with. Okay? So C says, explain why zeros you found in part A are not part of the solution set of the inequality. Well, where is this inequality? In other words, what are the x values where y is negative? So what I'm looking at here is what are my x values when y is negative? Or I think a little bit easier to realize is when you have zeros that are, in this case, this is not less than or equal to 0. This is going to be, this one here, I'm going to show you right here up top. It's strictly less than 0. So basically what's going to happen at negative 3 and positive 1 is it's going to set it equal to 0. So here I'm going to say the zeros, I think it's kind of funny to write that, the zeros make the quadratic equation equal to 0. And in this case, the solution must be less than 0. So this says write the solution set of the inequality and represent it on a number line. Number lines are a great way to understand what your solution set looks like. So I'm just going to slide this up a little bit. So in this case, my zeros are at negative 3 and 1. All right. Now, because there's no equal sign, I know I have to have open circles here. They can't be closed circles, right? Now pick a number in the middle of that. So in this case, I think the easiest number to pick would be 0. And plug it into your equation. So I'm just going to write the equation up here just quickly so we remember. Plus 2x minus 3 equals 0. So when you substitute 0 in here, I'm left with negative 3. So I'm sorry, I put an equal sign and it should be a less than sign. So in other words, what I'm saying here is I'm saying 0 squared plus 2 times 0 minus 3, is that less than 0? Well, these are going to go to 0, and is negative 3 less than 0? And the answer is yes. So if it's true for 0, it's going to be true for everything between it. So this is what my solution looks like. All right, now if you really wanted to be sure, you could try a number like 10 and see if that works. All right, so that gives you 100 plus, I'm sorry, 10. 100 plus 20 minus 3, is that going to be less than 0? And of course it's not going to be. So you can see how 10 would not be in the solution set to this inequality. So I think really the key is here is recognizing what numbers are in the inequality and what ones are not. And they're either going to be sandwiched between your two zeros, or they're going to be heading in opposite directions from those zeros. Okay, so write down what you need to. I will meet you at 3. So It says the key to algebraically solving a quadratic inequality is to first find the zeros and then test the points between the zeros and outside the zeros. Now, personally, I don't think you need to do both, but be careful, because if by chance you make a mistake, it really could cost you, especially something like this, which is a multiple choice question. So if we take a look at this, which of the following is the solution set of the inequality x squared minus 4x is greater than 0? So from here, before I even start looking at my solutions, I know this is the difference of two perfect squares, which is x plus 2, x minus 2 is greater than 0. So my zeros are going to be, now, do you have to do this all out? I think most of you would be able to do this in your head, but you get positive 2 and negative 2 being my zeros. So again, I really enjoy going to the number line and putting in my negative 2 and positive 2. And again, in this case, it doesn't happen all the time, but 0 does fall between them. So I'm going to test my 0. So I have x squared minus 4 is greater than 0. 0 squared minus 4 is greater than 0. Is negative 4 greater than 0? The answer is, of course not. So in this case, again, because we don't have an equal sign, we're going to have open circles here, all right? And instead of going between them and including the 0, they're going to be going in opposite directions. So that's what my solution set looks like. So you have to now make sense of between your number line and your answers. Well, one says x, remember what that line means, such that x is greater than 2. Well, that's part of it, but it's not all of it. So let's get rid of that. Number 2, solution number 2, so choice number 2 says that our x is sandwiched between negative 2 and 2. That is definitely not what we decided it was. All right, and again, number 4, it's greater than negative 2. Of course it's not. And then our answer is going to be answer number 3. X such that x is greater than 2, that's this piece right here, or x is less than negative 2, that's this piece here. So there's our correct answer. Moving on to exercise 4. I think you guys can pause the video at this point, and you can try these on your own. All right, even if you solve them and you get a little confused at the end, at least get them solved on your own, okay? Remember to write all your final answers in set builder notation and represent the solution on a number line. Okay, so let's take a look at A. So the first thing I'm going to do is I'm going to factor my x squared minus 5x minus 36 into x minus 9, x plus 4, which is less than or equal to 0. Now that equal sign there tells me that I'm going to have closed circles on my number line this time. So what are my answers? I have x minus 9 equals 0. I have x plus 4 equals 0. So here I'm going to have x is equal to 9. And here I'm going to have x is equal to negative 4. Now remember, they're not really equal. We're just saying that those are the zeros of the quadratic equation that we're considering. So in this case, I have negative 4 here, and I have positive 9 here. Now again, because I have this equal sign here, it's less than or equal to, I know that I'm going to have closed circles now sitting at my zeros. So I know it has to be less than. So again, it just so happens that 0 falls in the middle here. So I'm going to test my 0. So 0 is 0 minus 5 times 0 minus 36. And is that less than or equal to 0? So this goes to 0, this goes to 0, and negative 36 is less than 0. So I know that it's going to be between it. my less thans, and I don't know if you're going to get this and you're going to remember this, but the less thans are going to sandwich. So if you have this less than here and set up this way with the quadratic on the left, the 0 on the right, the less thans will be between the two zeros and the greater thans will be on the other sides of the zeros. So maybe you'll make that connection by the time we get through all of these. All right, so again, pause, try B. And I will put the solutions up in a snap. So just factoring that, that's what you come out with. So don't flip out that you get a fraction as one of your roots. Just recognize where on that number line that fraction will lie. All right? So if you think about negative 2 over 5, that's not, remember, negative 5 over 5 would be negative 1. So if this is 0 and this is 1, negative 2 over 5 probably would be somewhere around here. And it's going to be an open circle. And 6, so 0, 1, 2, 3, 4, 5, 6, also an open circle at 6. Not very drawn to scale, my apologies. All right, and because this is a greater than sign, I'm thinking they're going to go away from those zeros. So I can try 0 because 0 is not where I want it to be. So when you put your 0 in, you get 5 times 0 squared plus 28 times 0 minus 12 is greater than 0. These two go to 0, and is negative 12 greater than 0? The answer is no. So I'm not going to go between them. Like I said, usually with greater thans, and it's not usual, but anyway, with greater thans, you're going to go to the outside of our zeros. Again, if you don't remember that, it's just as easy to test the points and figure out where you have values that work. All right? If I show you what this looks like on a parabola, you'll understand it a whole lot better as well. All right? So the time will come where we do that. So pause, write down what you need to, and then I'm going to put the solutions up for C and D. Try them first. Be true to yourself. So as I was finishing up that C and D, I'm realizing that I did represent the answers in on the number line, but I actually did not do the part where it told us to represent it in set builder notation. So just taking a minute, whenever you have this situation right here on the left side, when you have two of them, you're going to have an or between them. So basically, how you do correct set builder notation is x such that x is going to be less than or is equal to 0, right? Solid circle, less than or equal to, or x is going to be greater than or equal to 7. All right, and then use those squiggles. Whenever you have it between the two zeros, again, x such that, what you're going to do is you're going to do negative 5, x, and positive 5. So your lower bound, your x, and your upper bound, always with less thans or less than and equal to's between it. Now, no equal to, these are not solid circles, so you're not going to put the equal sign in there. So that's how you would write those in set builder notation. So in just a second, I'm going to move back up and do A and B so you can see what that looks like. So this one right here, this is A. So because this is a sandwich, I'm going to do negative 4. I'm going to do positive 9. I'm going to put an X between it. Because these are solid circles, I'm going to put less than or equal to signs here. Now, if you wrote that, you would get full credit. But once again, proper set builder notation looks like that. And remember, when you have it going in different ways here in B, I'm going to have an or between it. I have open circles, so I'm going to have x is greater than 6, or x is going to be less than negative 2 over 5. Again, if you did it that way, perfect, except true x set builder notation looks like that. All right, so we do have 2 more to do. It's getting a little long now, so we're gonna kind of run through them a little quickly. I think these exercises really are what we want to focus on those. So please make sure you understand these before we move on to 5 and 6. The number line graph is the solution to which of the following inequalities? Well, just like I told you before, I'm going to just make this a little darker. Closed circle, and between it. So I know that proper set builder notation, well, they're asking us which quantity is this. Because this is a little trick, because it's between it, it's sandwiched, it's got to be less than, because the greater thans here and here are going to give us solutions away from our zero. So I know this is not my solution. Now, I also know that if I have solution zeros at x equals -4 and x equals 2, because remember that's not -5, that's -4, -3, -2, -1, 0, 1, and 2, I know my factors have to be x plus 4 and x minus 2, right? Multiply them out and you get x squared plus 2x minus 8. And I know it has to be, we have solid circles, so I know it has to be less than or equal to 0. All right, so actually, if you looked at it, these are exactly the same, except for our signs. So I missed that. If I knew they're solid circles, I know they have to be less than or equal to signs. So clearly, the answer needs to be number 4. All right, and 6 is asking a very similar question, except this time it's starting with the quadratic, and it's telling you what is the solution. Now let's see if we can cheat our way through this a little bit. We know that it's going to be a greater than, so we know it's going to be an or. So we know that these two are out. Oh, I love that. That makes it so much easier. All right, so now we're going to have to do a little bit of math here because we're going to have to do some factoring. And it's tricky to factor with that leading coefficient being a -2, but you could try working with your answers. In other words, here, if I have 1/2, I know that it's going to be x minus 1/2, and I know it's going to be minus x minus 3, right? So, and this one's going to give me x plus 3 and x minus 1/2. So you can see which of these is going to give that our solution. So you could multiply these out to see which one gives you that solution. And when you do that, this is the answer you get. If you try to factor it, this is what you would end up with. But again, you don't have to make things difficult. Go and use the choices that they give you. All right, learn how to take these multiple choice tests because sometimes it's just easier to work with the choices and eliminate two that just don't make sense. Because there's always going to be two that, or at least there always has to be one. There's most of the time there's two that you can get rid of right off the bat. Okay, so that is the end of it. So tomorrow in class, we will be doing the classwork for this, working together, using your calculator. And if I have time, I'll make sure I show you the trick about looking at the graph and trying to visualize what that graph looks like. Okay? Until then, make good choices, and I'll see you next time.